Hello, Geometry Honors. This is Kaczynski here with Lesson 13.3 Notes. We all wish that we were together in school. We would be learning and having a good time, but we're going to make the best of our situation. So with your 13.3 Notes, we would love it if you would please try the warm-up question, 3 graphs. It'll review what we did in Lesson 13.2 and Algebra 1. Go ahead and see if you remember the algebraic names for how to solve a system, and then go ahead and solve problems 1 and 2 because those are the kinds of systems that we did solve in semester 1. So please pause the video, try those out, and then join me again. All right, through the magic of technology, we're back. So take a second and look at your graphs, compare it to these graphs, and see if they match. If they don't, please reach out to your teacher or review your Lesson 13.2 notes. Now, why did we do this? Not just for fun, but we wanted to remind you guys that 2 lines might intersect at one point. So those are intersecting lines. In which case, the system of equations has one solution. In situation number 2, you saw parallel lines. And algebraically then, or no matter what, that system of equations has no solution. And what happened in situation number 3, it is the same line. Some places call that coinciding. And then what does that mean for us? It means infinitely many solutions. I can't spell. Let's try again. Infinitely many solutions. Now, all through semester 1, you guys used substitution and elimination, sometimes called linear combination, to solve all the systems that we asked you to solve. But every time we gave you a system, there was exactly one solution. So now, go ahead and check your algebra. I'll pause. I'll see if I can stop talking for 3 seconds. Check your algebra on 1 and 2. If not, reach out. If you did not get those, you need some help, reach out to your teacher for help. Let's look at situations 3 and 4 together. So it is your choice. Do you like substitution better? Do you like elimination better? They're both great. You'll use them in lots of different ways in Algebra 2 and Pre-Calculus. I'm going to zoom in. Hope that's okay. If it's not, just yell at me. All right, what I'm seeing on this guy right here is y is already by itself. To me, that's a perfect candidate for substitution. So here's what I'm going to do. We'll take the second equation, but instead of the y, we're going to substitute in the green value of x minus 3. Let's see what happens. Negative 2x plus 2x minus 6 equals minus 6. So our goal is now to solve for x, but take a look at that. Is anything weird happening? Uh-oh, they're gone. So you're left with negative 6 equals negative 6. Some students go one step further and they add 6 to both sides, and that's fun, but then I get too silly, and so we'll back it up a step. So you can do that. You can stop right there in the orange. Either one is cool. So what does that actually mean for us? I can't get a value for x or y. All the variables are gone, but what's left right here is a true statement. That means that every x that you choose, the y value you find will be a solution. So we do have infinitely many solutions. How cool is that? All right, exciting stuff happening there. All right, so that was our substitution review as well. Let's take a look at this guy, number 4. So you can do substitution or elimination, your choice. I don't know, my attention is just drawn right here. I feel like I want to eliminate the y. So I might multiply the top equation by negative 2. The goal with elimination is to get some opposites. So negative 2x plus 4y equals negative 6. That's the key thing on the elimination method, is don't forget to multiply every single term by your factor. Well, let's go blue. That'll be nice. So this guy can stay fine at 2x minus 4y equals 7. So we'll do what we're supposed to do. Add them together. A variable should eliminate. So this was the goal, to eliminate those guys. Uh-oh, what happened on the x's? They're gone too. So now I have nothing on the left side, but when I add my right side, negative 6 plus 7 is 1, it says 0 equals 1. That is not true. So no matter what x value or y value you choose, you will not find a solution. Those are parallel lines, so no solution. So if all the variables disappear and your statement is totally false, then that's a no solution scenario. All right, so we have two geometric / algebraic examples that we want to look at. Yesterday, you guys practiced medians and altitudes and perpendicular bisectors and all those fun things. So we'll do two problems together, and then you'll be able to try some stuff for the homework. Hopefully you enjoy it. So we purposely did not give you a coordinate plane. Sometimes it's nice just to have an approximation. So let's just do that. We'll wing it. No judgment, please, if it doesn't look perfect. We're in a safe place. All right, so 0, 6, we'll call that 0, 6. 10, 0, that's kind of big. It's not totally to scale. Negative 4, negative 6. All right. Jump. Boom. Boom. There we go. Sorry for the sound effects. I don't know how to graph any other way. All right, where does the median from A intersect the median from B? So just like you guys practiced, so you know that a median connects a vertex to a midpoint. So let's do this. Let's go ahead and find the midpoint there. I'll call that one, I'll call it M for midpoint. Why not? And so let's see. Negative 4 plus 10 is 6 divided by 2 is 3. Negative 6 plus 0 is negative 6 divided by 2 is negative 3. And then we also want the median from B. So I'm just going to eyeball that guy. Used M. I will call him N for, I don't know, call it whatever you want to. So 0 plus negative 4 divided by 2 gives us negative 2. And 6 plus negative 6 is 0. Divided by 2 is 0. So my picture is not totally to scale. That's okay. It's the best that we got. I think it's fine. So let's go ahead and connect those. I feel like we should. So review that those are segments. All right, so now where do they cross? I don't know. My picture's not accurate enough to tell from the graph, so we're going to have to do some algebra. So let's go with the red first. So I want to get an equation. Maybe I'll do my equations down here, and then we can go upstairs for a little bit. I don't know. Yeah, no, I guess we'll just start up high and work our way down. All right, so we want the median from A. So to write the equation of a line, you guys know that you need a slope and a point. So I need the slope for that. So 6 minus 3, 0 minus 3. So his slope is minus 3. Now I can do point slope using A or M. That would be fine. But I noticed that point A is the y-intercept. So I can go straight to slope-intercept form. So y equals negative 3x plus 6. So that was in yesterday's notes. All right, now we'll move on to the purple. So we want to get the median. That was a bad M. From B. So I need the slope. 0 minus 0. Okay. 10 minus 2. So, we haven't seen this guy in a while. Actually, no, we just saw it yesterday. That's true. So a 0 slope, turns out it's a horizontal line. And so when you review from yesterday, when you do write the equation of the horizontal line, what's y equals, and then the y value, the y coordinate of every single point on that line. So let me grab that highlighter. So now there's our red median, there's our purple median. We're looking for the point of intersection. The cool thing here is that they're already both y equals. So to me, that is a perfect substitution scenario. Love it when a plan comes together. I think I'll stay green here. So we have an x value of positive 2. Now, it's your choice. You can go to the red or purple equation to finish the problem. Pause for 1 second and think which one you're going to choose. And the correct answer is to choose the purple one because it's faster. So maybe I'll still switch colors. Why not? And then always read the directions. Sometimes we do a bunch of crazy things, but this just says what is the point of intersection. And so we'll switch colors. And so we'll call it 2, 0. Big bada boom. All right, that was a good time. So these were nice numbers. Sometimes they do get funky. I would always recommend using some improper fractions. I wouldn't use mixed numbers or decimals. All right, this last one could be fun. Let's find out. So again, I think a rough draft, a little rough sketch is helpful. That was not good. We'll try again. All right, let's see what we get. Negative 3, 7. So we'll decide that looks like negative 3, 7. 2, 3. U. Negative 5, negative 4. All right, so let's read this problem. We want the length of the altitude from F. Isn't it so beautiful that we started altitudes all the way back in chapter 3, and they're still with us in almost the last lesson of the entire school year? Math is amazing, just like all of you. So here we go. So you know, I guess we'll switch colors. You know that an altitude starts at a vertex and then is perpendicular to the opposite side. So medians are nice because we know they connect to a midpoint, but right now we do not know where the altitude even touches segment UN. So this is where our work from yesterday is going to pay off. So I guess I'll stay blue to write the equation of segment UN. So just like we did in the above problem, we need the slope 3 minus minus 4 and 2 minus minus 5. And that's amazing. I actually just made this problem up for you guys this year, and I did not intend for the numbers to even be that nice. So amazing. Now, we're going to use point slope. You can choose U. You can choose N. It doesn't matter. I like 2, 3. So I'm going to go with point slope form from yesterday. Y minus 3 equals the slope of 1, which some people don't like to write the 1. That's fine. And so I'll pause there for a second, or chances are, since you're, well, I don't know. Okay, that's fine. You convinced me. Keep going. Most people want to keep going. Okay. You asked, I listened. So we're going to distribute the 1, and then we're going to add the 3. And so there is the equation of segment UN. And then we also have the altitude from F. So we want to write his. Now here's the thing. How do I find his slope? I don't know the point. You're going to say the altitude is perpendicular. So the slope is perpendicular to this slope. So -1 is our slope. Now we want to use point slope. This is the only point that we know on that line or segment. So we're going to use that point. So y minus 7 equals slope of -1, x plus 3. Let's go ahead and distribute. I know you're going to tell me to distribute, so I'll just do it. I don't need to write the 1. That's not like me. So -x minus 3. So our red equation is y equals -x plus 4. So we want to find out where those two cross, because it is asking for the length, which means distance formula, but I can't do distance formula if I don't know the coordinates. So just like the previous problem, this one is already nicely set up for substitution. They're both y equals. That's amazing. Love it. So here we go. Jump in. 2x equals 3. So x equals 3 halves. All right. Now we need a y value. You can choose either the blue or the red. I think I like the blue. You take your pick. So y equals x plus 1. So y equals 5 halves. So let's go ahead and do this. Let's go Glenbard Green, go west. So we'll call this G for geometry, or G for Glenbard West. So now we have the coordinates. Where they intersect is 3 halves, 5 halves. So to finish the problem, it is asking for the length of segment FG. So you know that's going to be your distance formula or Pythagorean theorem. Man, ran out of room. Let's see. I guess I'll just start right down here under it. So distance formula from lesson 9.5. Here we go. x1 minus x2 squared plus y2 minus y1 squared. Now normally we would spend a lot of time making this beautiful and rationalized, except the problem is asking just to the nearest hundredth. So this is a time to just grab that calculator and go straight to the answer, in my opinion. So we can spend a bunch of extra time, but by the directions we don't need to. So hopefully you get 6.36. Thanks for watching Geometry Honors. We are here for you to help in any way. Don't be shy with questions. We miss you very much, and we hope you have an awesome day. Bye-bye.